Welcome to a lesson with Dr. Powell. Let's take a look at how we can use a spectral sequence argument to find a long exact sequence um, for a morphism between two chain complexes and its respective mapping cone. Well, first of all, what's a mapping cone here? Well, with our spectral sequence setup, let's think about this. We have a commutative diagram first with this morphism here, map between complexes, and we're going to do homology, so decreasing indices with arrows. So in our spectral sequence setup, if we're thinking about the total complex, kind of running like this, that's the mapping cone. It's just the total complex. Okay, so the spectral sequence is a nice natural thing to consider then, since the mapping cone is the total complex and we're working with that with the spectral sequence. Let's start off by taking homology with respect to horizontal arrows. And so in that case, we'd have HN would map down to like HNB. Okay. Let's even write the next one down. Okay. HN minus 1B. Okay. So, and we have vertical arrows between those homologies. Next, at the next stage, taking the vertical homology, we'd have, let's label this as alpha and this is beta. So really what we'd have is, at this point, we'd have the kernel of alpha, because we're modding out by 0 coming in. So it's just the kernel. And down here, similarly, it's the co-kernel, since the kernel's everything here. So we'd have a map. Actually, we don't have a vertical map anymore. The map's different, but at least let's just write down what they are right now in those locations. The kernel of alpha, right here, we'd have the co-kernel of alpha, and similarly, right here, we'd have the kernel of beta and the co-kernel of beta. All right. So we have a start. We have a map between this guy and this guy. Let's see where we can go with that. We know that this right here will surject onto the co-kernel. In fact, let's just kind of make some room over here to consider what's going on. So we know that Hn of A will map to Hn of B, which will surject onto its co-kernel of alpha. Just naturally, that's what you can do with the co-kernel there. The quotient of this with that. So yeah, it's a quotient, it surjects onto it. And then let's see what happens with this. Now, at this point, the maps actually from here gonna go, let's see, we're going this way, that way, and then we're going that way. So it'll come from here, 0, 0. So it actually stabilizes right here, which now stabilizing means that we actually, and since this is at this end of it, we started up here, but at the end, it's a sub-object, which means that this actually is a sub-object of the, let's let C stand for the total complex, and we'll just index this in such a way that it's Hn right there. Okay, so it injects into this. Now, we also know something else, that Hn of C will surject. Okay, so let's just kind of go like this. We'll surject onto a quotient, which we get stabilizing right here as well. So in that diagonal right there, so it'll surject onto that kernel. The kernel of beta, which naturally injects into that part right there. Now let's just analyze what we have right now. Now, let's see, it looks like the combined map from here to here factors through the kernel. So its image, in fact, its image is the kernel. So it means that you get exactness right here in this sequence if you're mapping from here to here, which is really nice. Now, what about right here, since this is a co-kernel, I mean, the image is the kernel of that map. So we get exactness here. The only question is, what about exactness here? And that actually comes from the fact that we have to use the fact that what we get in this diagonal is quotients in a filtration of HNC. And so that's a fact about what we get in stabilizing. So HNC, we have different things coming into it. So let's just, for filtration, I'll use an F maybe. And I'm not really using my indices really well, but I'll just say F1 and F2, say something, you have something like this. Or now, and maybe perhaps actually we just need 0 here. Okay. And we could just say F filtration. Now, the whole point is that these guys right here are actually the quotients in that filtration. They pop up right here, which is a great thing to be able to use, and we kind of need it right now. Where this guy right here, this part is the sub-object, and it's the quotient of just this guy with 0. So co-kernel of alpha. And this guy, the next guy up right here, is the next quotient. So kernel beta is the next quotient. Okay, well, notice that as we surject onto beta, guess what the kernel is? The kernel is just going to be the F itself right here, which happens to be the co-kernel of alpha as we take quotients. So like Hn of C over F is going to be kernel of beta, but F is just co-kernel of alpha. So the kernel is co-kernel of alpha here. And so we actually get, so the image of this is actually the kernel of this next map where we surject onto the kernel of beta. So we get exactness here as well. So we get a long exact sequence of homology, just using the spectral sequence argument and thinking about how spectral sequences work. We kind of needed to use this idea of filtration here as we look at this diagonal. And so we know this is a sub-object, this is a quotient, but that's just because it's at this end of the filtration versus that end of the filtration. But since there's only 2 non-zero things in that diagonal, it's a very simple filtration, and I got it. So so fully we have HNA, HNB maps to HNC. So mapping cone, which is just the total complex there, which maps to Hn minus 1 of A, which maps to Hn minus 1 of B. So we have a long exact sequence of homology coming using the mapping cone. Thanks for watching.